Welcome to Montessori Education.
మాంటిసోరీ ఇంగ్లీష్ మీడియం స్కూల్ అడ్మిషన్లు జరుగుతున్నవి. మాంటిసోరీ ఇంగ్లీష్ మీడియం స్కూల్, బుర్రిపాలెం రోడ్, తెనాలి. ఫోన్ 08644227115.
Hello and welcome to video number 17. In previous video we have learned that how HCl gas reacted with the blue litmus paper, dry and wet. Their H plus ions are responsible for changing of wet litmus paper. Because how means the hydrogen chloride having H plus ions, when reacted with H2O it gives H3O plus ions, H3O plus ions. So I said this is responsible for the change in the litmus paper, blue litmus paper. So H3O plus ions or H plus ions, both are responsible, means H plus ions or H3O plus ions are responsible for the change in litmus paper, blue litmus paper turns to red. So these are called hydronium ions. Hydronium ions. If you take bases, I asked before question that what changes does occur when bases reacts with water. If you take base NaOH, when it is reacted with water H2O, it gives Na plus plus OH minus ions. OH minus ions. Likewise, if you take KOH, potassium hydroxide H2O, when it reacted with H2O, it gives K plus plus OH minus ions. Here also OH minus ions. If you take magnesium hydroxide, MgOH twice in water, it takes Mg plus 2 plus 2OH minus ions. So here all OH minus ions, these are also responsible. So here see OH minus, OH minus, OH minus. These when reacted with water, these also form some ions. Like acids, these also forms ions in aqueous solution. So these are also responsible for changing color. Bases means what? If you want to tell that is a base, how could you say? The red litmus paper changes to blue. So here OH minus ions are called hydroxide ions. You call it as sodium hydroxide, sodium hydroxide, potassium hydroxide, magnesium hydroxide. So all OH minus ions are called hydroxide ions. All H plus ions are called, or H3O plus ions are called hydronium ions. So all bases are alkali. Listen carefully. All bases are alkali, but all alkalis are not bases. All bases are alkali, but all alkali are not bases. Alkali means salts. All bases are salts, but all salts are not bases, because some bases does not dissolve in water, that are not soluble in water. That insoluble are called alkali but not bases. Some, for example, beryllium hydroxide BOH twice, it is slightly soluble in water but not totally, so that is also insoluble maximum. So this type of are called alkali but not bases. So sodium hydroxide is called base, so it is also called alkali, so because it dissolves in water. KOH is a base. It is also salt, alkali, because it also dissolves in water. That's why I am saying all bases are alkali, but all alkali are not bases. Next topic. What do you observe when acids or bases mixed with water, or when water is mixed with acids or bases? What are the observations? So let us see that in some containers like concentrated sulfuric acid and concentrated NaOH tins, on the tins some signs, danger signs will be there, like this they will give. It does not directly fall on hand, or it does not fall on any metals, it will corrode. Like this signs will be there in on the containers. So why these signs are written on the containers? Is there any reaction when these acids or bases are directly added to water? So what happens when these are added? Let us take some concentrated H2SO4 solution and also concentrated NaOH solution. Keep it aside. Take 2 test tubes. Slowly add concentrated H2SO4 into the test tube. When you hold the test tube, what do you observe? Same manner you add NaOH solution to another test tube. See what reactions they occur and what happens. In both you observe that NaOH and H2SO4, you observe that both exerts heat. H2SO4 or NaOH, both exerts heat. So here exertion of heat means nothing but liberation of heat. Both will liberate heat. When you touch the test tube, you will feel some hot. You will feel some hot due to the presence of sulfuric acid in the test tube or NaOH solution in the test tube. Means liberation of gas, liberation of heat is done there. Liberation of heat is there, so that when you touch the test tube, you will feel hot. That liberation of heat is nothing but the process. It is called, you all know that exothermic process. What is exothermic process? Liberation of heat is called exothermic process. Endothermic process, absorption of heat is called endothermic process. So here, when you pour a little amount of H2SO4 in test tube or NaOH solution in test tube, some heat is liberated. So this process is called exothermic process. And you see, the main question is first, see, is acid must be added to water or water should be added to acid? There is a difference between them. Should acid be added to water or water should be added to acid? Here always listen, always acid should be added to water. Small few drops of acid should be added to water. This is a beaker. If you take water, you have to add acid to water, but not water to acid. If you add water to acid, it will react more, and the acid may split and fall on us, so that it may cause burning. So every time you should add acid to water, not water to acid. So anywhere you should add acid to water. So see what happens. When you add acid or base to water, it will dissolve in water or diluted in water. So that solution is called dilute solution. Means the concentration of that particular acid will diluted, means decreases. The concentration will be decreased. So that decrease, that solution we call it as a dilute solution. If you take lemon juice, lemon is concentrated. When you directly take it, it will be more sour in taste. If you add it in water, 1 glass of water, the sourness of that lemon will be decreased. Means what? The concentration of lemon is decreased by adding water. So that means what? The concentration is decreased, means it is diluted. So here, like that, when the acid is added to water, its concentration is decreased. That means the solution is diluted. So we call these solutions as dilute solutions. So in this, always you should add acid to water. You should not add water to acid. If you do like that, local heating will be there. Local heating means high amount of heating will be evolved, so that the acid may splash out. For that reason, you have to add always acid only to water. This is main important. One more question asked in the exam. Let us see next. Till now you have learned that what is acid base, and how you identify acid and base. How you identify acid and base? By using litmus papers, methyl alcohol methyl orange solutions, phenolphthalein solutions, like that used and tested whether it is an acid or base. But how can you say that this acid is strong and this base is strong? This acid is weak and this base is weak. How can you say? So in order to learn that, a concept was given, that is nothing but strength of acids. Strength of acids. As we done in previous activities, we have done an activity that acid solutions conducts electricity. There you have taken different acids and seen that the bulb glows. Here also take same activity. Take two solutions. Take two solutions, acid solutions. One is hydrochloric solution dilute, and another is diluted CaCO(H), nothing but acetic acid. Do separately these activities. Same, one beaker, two graphite rods. It is connected to plug and it is connected to bulb in order to show the intensity of the bulb. So see these both activities with differently and observe where the bulb glows high. So when you add HCl, the bulb glows high. When you add CaCO(H), the bulb glows intensity is low. When you see in HCl solution, the bulb glowing intensity is more when compared to the solution CaCO(H). What is the reason behind them? Why the bulb glows brighter in HCl